There's something happening right now that you didn't start, not breathing, though that too. Something quieter, a background hum of selfhood that's been running since before you had a name for it. You didn't turn it on this morning. You won't turn it off tonight. It just continues. The fan in the corner of the room cycles on. You probably stopped hearing it hours ago. That's what this is like. The sense of being you is so constant, so unbroken that it stops registering as a thing that's happening. It becomes the air, the floor, the default. And because it never flickers, not usually, not in ordinary life, you never really have to ask where it comes from. But it comes from somewhere. There is a region of tissue at the back of your head, just above the neck, that never fully goes quiet. Even in deep sleep, certain neurons here maintain a low, steady pattern of firing. Not alertness exactly, something more like a biological baseline, a minimum threshold of self-referential processing that the brain appears to hold on to even when consciousness dims. Neuroscientists sometimes call this the default mode network, though that phrase undersells how strange it actually is. It's not the network that activates when you do something. It's the one that runs when you're doing nothing in particular, when you're sitting, waiting, half awake. And what it does mostly is think about you, not in a narcissistic way, in a functional one. It rehearses past events, runs forward simulations, checks relationships, monitors for threat. It narrates, it contextualizes. It generates a continuous low-resolution story in which you are the protagonist. You didn't ask it to. It just does. There's a word, ipsati, that some researchers use when they want to describe the raw, pre-reflective sense of being a self. Before thought, before language, the immediate bodily feeling that this experience is happening to someone, and that someone is you. It's not a philosophical conclusion, it's more like a texture. And what's interesting, what I keep coming back to, Dee, is that this texture seems to be constructed, not discovered, assembled from inputs you don't consciously control, and then presented to you as if it were simply there, simply obvious, simply you. The inputs are physiological. Signals from your joints and muscles about where your body is in space. Signals from your organs about their current state. Full, empty, tense, calm. Signals from your immune system, your endocrine system, your gut. Signals from memory networks that carry a compressed archive of your history. All of it converging constantly into a working model. A model called you. This is not a metaphor. That's the part worth sitting with. The self isn't stored somewhere like a file. It's generated. More like a process than an object. More like a flame than a stone. Which means it requires ongoing conditions, ongoing inputs, ongoing tissue. If you've ever had a high fever, really high, the kind where the world becomes slightly wrong and you feel strangely beside yourself, you've brushed up against what happens when those conditions waver. The self doesn't vanish, but it loosens. It gets imprecise around the edges. That looseness is informative. It suggests the usual tightness isn't inevitable. It's maintained. Something keeps saying I because something keeps working to say it. You've probably never thought of identity as a biological effort. Most people haven't. It's easier to imagine the self as a fixed thing, something you have, rather than something your nervous system is constantly producing. But the production is real, and it's never not happening, and it involves more of your body than just your brain. Your heart sends more signals to your brain than your brain sends to your heart. That's not a poetic detail, that's the actual anatomy of the vagus nerve, the longest cranial nerve in the body, running from brainstem to abdomen, carries information upward, gut state, cardiac rhythm, visceral pressure, and that information feeds, in ways still being mapped, into the circuits that construct your sense of self. You feel yourself in part through your organs. The stomach knows something. The chest registers something. Not thought, not exacted, but input. Biological data that gets folded into the ongoing model. There's a condition called depersonalization, where the signal breaks down. People describe it as watching themselves from outside, as if they've become a spectator of their own life. Everything is familiar, but nothing feels owned. Actions happen, but they don't feel like theirs. It's distressing when it happens, genuinely disorienting, but it's also, in a way that takes a moment to appreciate, revealing. Because it shows that the normal state, the ordinary feeling of inhabiting yourself, is not guaranteed. It's not a given. It's the output of a system. And like any system, it can malfunction. Most of the time it doesn't. Most of the time it runs so smoothly you forget it's running at all. Like the fan, like the floor, somewhere in the tissue at the back of your skull, neurons are cycling through patterns they've been cycling through since you were small. The default network is idling. The body is sending its reports. The model is updating slowly as it always does. And something keeps saying I. Not loudly, it doesn't need to be loud, it just persists. Quiet and uninterrupted, the way certain biological things are. Not because they're trying, because stopping would require something the body doesn't have a mechanism for. Somewhere below the level of thought, the signal continues. The organs keep reporting, the networks keep assembling. And what they're assembling, what they've always been assembling, is the particular, strange, utterly ordinary fact of being you. The body doesn't just know where it is in space, it has a continuous low-level sense of its own interior, a running account of pressure, temperature and state that most people never consciously read. That account is older than language, older probably than sleep itself, before thought. Before the particular arrangement of memories and preferences and accumulated embarrassments that you call yourself, before all of that, there was a body that knew where it was. Not new in the way you know things, new in the older sense, the sense that doesn't require a mind to contain it. There's a smell in the air tonight, something faintly green, like rain that hasn't arrived yet. It doesn't mean anything, it's just there. And without thinking, without deciding, your body has already noted it, logged it somewhere below the level of attention, filed it under environment, current, unthreatening. That filing happens before you do anything. There's a system in your body that's been running without interruption for as long as you've been alive. It has no central location. It doesn't announce its findings. It operates through a dispersed network of receptors in your muscles, your tendons, your joints, the soles of your feet, each one sending quiet, continuous signals about position, load, and movement. Proprioception, from the Latin proprius, one's own. Ception, to receive, receiving what is one's own. The naming is almost too tidy for how ancient the thing itself is. Proprioception predates vertebrates. Something like it exists in insects, in crustaceans, in organisms that haven't had a centralized nervous system for hundreds of millions of years. The need to know where the body ends and the world begins, that need is not a human invention. It is one of the oldest biological problems, and the body solved it long before anything we'd recognize as a self came along to benefit from the solution. Right now, without your involvement, your spinal cord is receiving position reports from roughly 250 joints. Each one is embedded with mechanoreceptors, specialized cells that deform under pressure and convert that deformation into electrical signal. They're not dramatic about it. They don't alarm, they simply report continuously the way a low-frequency transmission reports. Steady, steady, steady. Your ankle knows it's bearing weight. Your shoulder knows its angle. The small muscles along your spine, the ones you've never consciously felt, are registering the exact degree of your current posture and sending that information upward along pathways you'll never trace. And from all of this, the brain constructs something. Not a map exactly, something more dynamic, a working model of the body in space updated continuously, maintained without effort. Neuroscientists call it the body schema. And what's worth sitting with is that this schema exists whether or not you're paying attention to it, whether or not you're awake, whether or not there is, in any meaningful sense, you currently present to receive it. I've always found it strange, and I don't think strange is the wrong word here, that this system operates most cleanly when you're not thinking about it. Try to consciously manage your balance while walking, and something tightens. Athletes know this. Dancers know it in a specific technical way. Too much attention to a movement disrupts the very automatic processing that makes the movement fluid. The proprioceptive system doesn't want supervision. It was solving the problem before consciousness arrived, and it continues to solve the problem around consciousness, alongside it, mostly without asking for input. Which raises something quiet and slightly uncomfortable. In what sense is the body yours if it functions best when you leave it alone? Not a philosophical question, a biological one, and the biology doesn't fully resolve it. There's a clinical condition called proprioceptive loss, rare, but documented. Most famously in a patient known in the literature as Ian Waterman, who at 19 lost all proprioception below the neck following a viral illness. Not paralysis. He retained motor function, but without sensory feedback from his body he couldn't move, couldn't stand, couldn't lift a cup without watching his own hand. He relearned eventually. Through extraordinary effort and years of conscious visual compensation, essentially doing manually what the proprioceptive system does automatically. Watching himself perform every action, substituting attention for signal, he managed, but the effort required was total. Exhausting in a way that's hard to imagine from the inside of an intact system. What his case made visible, starkly, in a way that textbooks struggle to convey, is that the ordinary sensation of inhabiting your body is not passive. It is the output of active biological work. Work you don't feel, because it never stops. Work that has been running quietly and without complaint, since you were a cluster of cells learning to organize themselves into something with a front and a back and a sense of which way gravity falls. The extended metaphor here, and I'll let it dissolve before it gets too heavy, is of a cartographer, one that never sleeps, never rests, never puts down the pen, constantly redrawing the same map with minor corrections. The coastline shifts slightly, a new weight is added, a joint reports a new angle. The map is never finished. But it's never wrong for long either. The corrections arrive faster than the errors accumulate. And so the body stays oriented, perceptibly, to itself, to the floor, to the space around it, without ever quite being aware that orientation is something it's working to maintain. By the time you perceive your own body, the cartography is already done. The edition you're reading is already out of date. Somewhere below the level of perception, a newer version is already being drawn. Evolutionary time does something strange to the way this feels when you sit with it. Proprioception didn't evolve for you. It evolved for something that needed to survive in a physical world, to catch, to flee, to land without breaking. The version running in you right now is a heavily modified inheritance, refined across lineages that no longer exist, passed forward through extinctions and adaptations and branching points you'll never be able to trace. And yet here it is, still running, still filing its reports, completely unconcerned with the fact that you're lying still in a quiet room, not fleeing anything, not catching anything, just here. It continues anyway, because it doesn't have a mode for stopping. There's something in that worth resting with, not the philosophy of it, just the plain biological fact. Your body arrived in this moment with its full ancient apparatus intact. Everything your ancestors needed to stay upright, to navigate, to persist, it came with you. You didn't earn it. You didn't learn it. It was already running when you opened your eyes for the first time, and it will still be running faithfully and without drama long after you fall asleep tonight. The body that arrives before you do, it's always a little ahead, always already oriented, already filing the next report before the previous one has finished arriving. And underneath proprioception, beneath even that constant positional hum, there is another layer, quieter, more interior, less about where the body is in space and more about what the body is doing on the inside. Pressure behind the sternum, the low, indistinct sensation of a full stomach, something in the chest that shifts when a feeling moves through. This is a different kind of knowing, older in some ways, and considerably stranger. Something is happening in your chest right now, not your heartbeat, though that too. Something less rhythmic, a kind of pressure, or the absence of pressure, a state. The chest has a state, and it's been reporting that state to your brain this entire time, and you've been mostly not noticing. That's not inattention, that's just how it works. The signals your body sends inward, from organs, from gut lining, from the fine nerve ending threaded through the walls of your blood vessels, these don't arrive as clear messages. They don't label themselves. They don't say, this is hunger, or this is unease, or this is the particular fatigue that comes from a day that asked too much of you. They arrive as raw sensation, unlabeled, unformatted, and then the brain does something with them. Interoception's the word for this. The perception of the body's internal state, not proprioception, that's the outside of the body, the joints and muscles, the spatial position. Interoception is the inside, the viscera, the slow, wet, pressurized interior that most people never think about and yet feel constantly. You feel it right now, probably in at least 3 places simultaneously. The weight of your own abdomen, a slight dryness in the throat, or the absence of it. Something in the belly, content or unsettled or simply present. These sensations have been reaching your brain your entire life. Via the vagus nerve mostly, that long wandering cable that runs from brainstem through chest and into abdomen, carrying more information upward than downward. Via the spinal cord, via a slower chemical signaling that moves through the bloodstream rather than along nerve fibers, all of it converging, all of it feeding into something. The room has gone very still. Outside, something, a car or an animal, moves briefly and then doesn't. There's a region of the brain called the insular cortex, tucked inside a fold hidden from the outer surface, not visible unless you pull the temporal and frontal lobes apart. It's one of the older cortical structures, and it appears to be where interoceptive signals arrive, get sorted, get integrated with memory and context and emotional history. The insula is not the only structure involved, but it's central. And what's interesting about it, what I find myself returning to, is that it doesn't just receive interoceptive information. It seems to participate in generating the subjective feeling of having a body at all. Damage to the insula can produce strange distortions. People report feeling detached from physical sensations, or unable to locate where a feeling is coming from. The body keeps sending signals, but the processing that makes those signals feel owned, felt from the inside rather than observed from outside, that processing is disrupted, which suggests something. The feeling of being inside your own body is not automatic. It's computed, constructed from signals, filtered through structure, assembled into the particular intimacy of first-person experience. Most animals have some version of this, the capacity to sense internal state, to register need, deficit, surplus, is ancient. Hunger, thirst, pain, these are interoceptive signals in their most basic form. The body noticing it requires something. The body sending that noticing upward toward whatever processing can act on it. In humans, the system became something else too, not just need detection, something more continuous, more textured, a running background sense of how the body is doing, not urgently, not in alarm, just currently. This is what some researchers call the sense of the body's physiological condition. Not a feeling in the way joy or dread are feelings, more like weather, background weather, the ongoing atmospheric state of being embodied. You felt this shift without knowing it was shifting. The difference between 2 p.m. and 4 p.m. on a day when you haven't eaten. Not hunger exactly, not yet, but something that changes the texture of thought. Things feel slightly more effortful, slightly less interesting. The world dims a half degree and you don't always know why. That's interoception. Or rather, it's the downstream effect of interoceptive signals reaching the circuits that shape attention and motivation. Blood glucose dropping, gut peptide shifting, the vagus nerve updating its reports, and all of it arriving not as a clear message but as a change in weather. There's something worth sitting with here, and it doesn't entirely resolve, which I think is honest. Emotions, at least partially, appear to be interoceptive predictions, not in a reductive way, not in a way that makes them less real, but the current understanding in effective neuroscience suggests that what we call emotions are partly the brain's interpretations of body state, predictions about what the interoceptive signals mean, run through filters of past experience, context, language, culture. Your heart rate rises, your gut tightens, your chest does the thing it does, and the brain looks at all of that, at the interior weather, and makes a guess. Excitement, fear, the particular specific feeling of being in a room with someone you haven't seen in a long time. The body sends the signal, the brain writes the caption, sometimes the caption is wrong. That last part is strange to consider at night, when everything is quiet and there's nothing particularly requiring interpretation. The interoceptive system is still running. The vagus nerve is still sending its reports. The insula is still processing. But without urgency, without context, without the particular inputs that require the brain to generate a strong emotional response, the interior weather settles. Not silence, not absence, just a low background hum of ongoing heartbeat, gut pressure, the slow, barely perceptible rhythm of the breath moving through the chest, the body reporting that it is here, that it is, for now, fine, that nothing requires immediate interpretation. And somewhere in that unremarkable reporting, in the ordinary, unexciting interoceptive signal of a body at rest, there is something that contributes to the sense of being a self, a continuous located self, one with an inside, one that feels like home most of the time, without you ever deciding it should. The inside weather, it was never nothing. You just stopped noticing it became familiar. Below all of this, below the organs and the vagus nerve and the insular cortex working its quiet assembly, there's another layer of self-recognition, one that doesn't operate through sensation at all, one that looks outward and asks a different question entirely. whether anything looking back is the same kind of thing. In 1970, a psychologist named Gordon Gallup Jr. put chimpanzees in a room with mirrors. Not for the first time in the history of primate research, but for the first time with a specific quiet question: would they recognize themselves? The first few days they treated the reflection as another animal. Threat displays, vocalizations, the usual social responses. And then something shifted. They began using the mirror to inspect parts of their own bodies they couldn't otherwise see. The inside of the mouth, the top of the head. A small mark Gallup had placed on their forehead while they slept, just a dot of odorless paint, detectable only visually. They touched the mark on their own face, not the reflection, their own face. This became the mirror test. And the list of species that pass it is strange and specific in ways that still don't entirely make sense. Great apes mostly, bottlenose dolphins, orca, Asian elephants, though not all individuals and not consistently, European magpies, which surprised almost everyone, and humans beginning somewhere around 18 months of age, when the neural architecture required has had enough time to assemble itself. What the test measures is debated. Some researchers argue it tests self-recognition in a narrow visual sense, nothing more. Others think it taps into something deeper, a capacity for self-modelling, for holding a representation of oneself as a distinct entity in the world. It's not entirely clear which they're right about. Possibly both, possibly neither fully. The bedside glass has a faint smear on it from earlier. You probably didn't notice it until just now. What's biologically interesting, mummies? What stands out when you look at the neurological data rather than the behavioral data is that mirror self-recognition appears to correlate with specific neural structures. Spindle neurons, also called von Economo neurons, are found in large numbers in the anterior cingulate cortex and the frontal insula of species that pass the mirror test. They're large, fast, sparsely branching cells. They seem built for rapt integration of social and interoceptive information. Humans have them, great apes have them, cetaceans have them in extraordinary numbers. Sperm whales have more von Economo neurons than any animal yet measured, including humans. Whether these neurons cause self-recognition or simply correlate with the kind of brain complex enough to support it, that's still open. But the distribution is not random. They cluster in the species that seem, by behavioral measures, to carry some version of a self-concept. The evolutionary timeline here does something uncomfortable to the concept of selfhood if you follow it too carefully. Self-recognition in the mirror test sense appears to have emerged multiple times independently, once in the primate lineage, separately in cetaceans, separately possibly in corvids. Not a single evolutionary event passed forward in an unbroken line, but a solution arrived at through different biological routes in different lineages, facing different pressures, which means it wasn't inevitable. It wasn't the destination toward which evolution was headed. It was, like most things in biology, contingent. A particular answer to a particular set of pressures stumbled upon more than once because the pressures themselves kept recurring. The pressure, probably, was social complexity. Living in groups where tracking relationships, modelling other minds, and maintaining a stable sense of one's own position within a social hierarchy offered survival advantages. The self, in this reading, is partly a social technology, a tool for navigating other selves. I find this reading compelling, though it's worth being careful with it. It doesn't mean the self is only social, it doesn't mean it's not real or not felt from the inside as immediate and unquestionable. It means that the neural architecture supporting self-recognition may have been shaped over evolutionary time by the particular demands of living alongside others who also had selves. The mirror, in this sense, is not just a reflective surface. It's a proxy for the social gaze. The question the brain is answering, when an 18-month-old touches the mark on its own forehead, is the same question social animals have been answering for millions of years in a different register. Is that me? Where am I in relation to what I'm looking at? Somewhere around the same developmental period, 18 to 24 months, children begin to show another behavior. They start to talk about themselves in the first person. Before that, many refer to themselves by name, as if observing a third party. Mia wants milk. Tommy fell down. Then something consolidates. The third person collapses into the first. The observed self and the experiencing self, which may have been somewhat separate in early development, merge into a single grammatical position. I want, I fell. The neuroscience of this transition is not fully mapped, but it appears to coincide with the maturation of prefrontal circuits, the thickening of certain white matter tracts, and the establishment of more stable connections between the default mode network and the regions processing bodily self-experience. The self, in other words, is still being built at that age, assembled from components that come online at different times, in a sequence partly genetic and partly shaped by experience. What strikes me, and I'm not sure this is a comfortable observation, is that the self is younger than the body that carries it. The proprioceptive system was running before birth. Interoception was running. The basic biological apparatus of embodiment was already functional, already filing its reports, already maintaining the body's model of itself in space. The self, the thing that looks in the mirror and recognizes, came later, was added, was assembled from structures that had other functions first. It arrived into a body that was already there, already oriented, already in its quiet biological way, doing fine without it. Whether a magpie has anything like a subjective sense of itself, whether there is something it is like to be a magpie noticing a mark on its own throat, remains genuinely honestly unknown. The behavior is there, the neural correlates are there in modified form, but the inner experience, if any, is not accessible. That gap between the behavioral evidence and the subjective reality doesn't close. Not with better technology, not with more careful experiments, it just stays open. A permanent uncertainty at the center of the question. Something recognizes, whether something feels itself recognizing. That's the question that doesn't resolve tonight. The body keeps sending its reports. The insula keeps processing. Somewhere in the circuits that matured slowly through childhood, the first-person position holds, steady, unquestioned, so familiar it stopped feeling like anything at all. But underneath the familiarity, the biology is still doing its work. The self-model is still being maintained. The anterior cingulate is still integrating. The spindle neurons are still firing in their particular rapid way, and the face in the mirror, if you were to look, would still be recognized, immediately, without effort. The recognition so fast it arrives before you've decided to recognize anything. At some point tonight, before sleep arrived, or while it was still deciding whether to, your mind went somewhere. Not somewhere real, not a decision, just elsewhere. A conversation you haven't had yet, a version of tomorrow that probably won't happen exactly that way. Someone's face arriving without invitation, connected to nothing obviously present. You probably didn't notice the moment it started. That's the nature of it. The wandering begins below the threshold of intention and surfaces only when something, so a sound, a discomfort, a return of attention, pulls you back. Back to what exactly? Back to here, to the ceiling, to the particular weight of being in a body in a room. There is a network in your brain that activates when you stop doing things. This sounds wrong when you first encounter it. The brain, you might assume, quiets when you are not actively engaged, rests, conserves, idles in some low-power state. And in some regions that's true. But in others, the opposite happens. A specific, anatomically consistent set of regions increases its activity precisely when external demands decrease. The medial prefrontal cortex, the posterior cingulate, the angular gyrus, the hippocampus and its surrounding structures. These regions, when you are task-free and unfocused, begin a particular kind of coordinated firing, synchronized in ways they aren't during deliberate, outward-facing thought. This is the default mode network, named somewhat dryly for the mode the brain defaults to in the absence of other instruction. It was identified almost accidentally. In the late 1990s, neuroimaging researchers noticed a consistent pattern of deactivation in certain brain regions when subjects were given a cognitive task. The regions quieted when thinking began, which implied they had been active before the task started, which implied that rest wasn't what they were doing. What were they doing? The honest answer still is, we're not entirely sure. But the picture that has assembled over the following decades is specific enough to be interesting. The default mode network appears to be involved in autobiographical memory, retrieving and re-examining personal history, introspection, imagining future events, running forward simulations of possible scenarios, in mentalizing, modeling the minds of other people, imagining what they think and feel, in self-referential processing, evaluating information in terms of its relevance to oneself. All of which is to say, when the brain is left to its own devices, it thinks about you, about your past and your future and the people around you and how you fit into things. This is what the wandering mind is actually doing. The pillow has shifted slightly from where it was an hour ago. You adjusted it without noticing. There's something quietly strange about this, if you let it land. The network that activates during mind wandering is not random noise. It's not the brain simply misfiring in the absence of direction. It has consistent anatomy, consistent functional correlates, consistent developmental trajectory. It matures slowly through adolescence and early adulthood, which may partly explain why younger children's minds wander differently, less narratively, less self-referentially than adults. It is, in some meaningful sense, the network of the self, not the only one, not sufficient on its own. But the default mode network produces something that no other network quite does, a continuous, temporally extended narrative in which you are the central character moving through time. Past events connected to present state, connected to imagined futures, a story with a consistent protagonist. You. I tend to think, and this is reading, not a certainty, that mind wandering is underrated as a biological function. It has a poor reputation, associated with distraction, with reduced performance on sustained attention tasks, with the particular mild guilt of realizing your mind has been elsewhere for several minutes. Mindfulness practice is often framed, at least in part, as a corrective to mind wandering. Return to the breath. Return to the present. The wandering is the problem, the returning is the practice. But the default mode network didn't evolve to create a problem. It evolved, or was co-opted, or emerged from structures that served earlier functions, because the kind of processing it performs appears to be genuinely useful. Rehearsing social scenarios, consolidating autobiographical memory, preparing for futures that haven't arrived, running simulations that cost nothing because they never leave the brain. The wandering mind is a planning mind, a social mind, a mind maintaining its own continuity across time. What's less certain, and worth being honest about, is the relationship between the default mode network and conscious experience. When your mind wanders and you find yourself unexpectedly in the middle of an imagined conversation, is that the default mode network causing the experience, generating it? Or is the network activity the substrate from which experience emerges in ways that still aren't fully understood? This is where the neuroscience becomes genuinely cautious. The correlations are robust, the anatomy is consistent, but the step between observed neural activity and subjective felt experience, that step remains stubbornly, incompletely mapped. What we can say, the default mode network is active. What we cannot fully say, what that activity is like from the inside, or whether like from the inside is even a question the network can answer about itself. There's a finding worth knowing quietly. In studies using experience sampling methods, where subjects are interrupted at random moments during their day and asked what they were just thinking, mind wandering is reported more than half the time. In some studies, significantly more. The mind, left to its own moment-to-moment freedom, spends more time elsewhere than here. This is not a pathology. It is apparently the default. The present moment for human consciousness is not the natural resting place. The natural resting place is somewhere slightly displaced in time, yesterday or tomorrow, or an imagined version of a conversation that happened differently in the rehearsal than it did in reality. Sleep changes this. As you move towards the sleep, the default mode network's activity shifts, not slancing exactly, but reorganizing. The autobiographical narrative loosens. The future simulations become less coherent, less governed by the logic of waking life. The characters in the imagined conversation start behaving strangely. Timelines collapse. This is the hypnagogic state, the threshold. And it may be in part the default mode network releasing its grip on the waking self-narrative, allowing the tight, continuous, temporally coherent story of you moving through your life to soften into something less structured, something the brain can work with differently. The loosening is not a failure, it's a transition. The network that spent your waking hours assembling your story is preparing in its own way to let the story pause, not stop. The default mode network doesn't fully go quiet even in sleep. Certain regions remain active through the night, particularly during REM, where something like narrative, something like self-reference, continues in altered form. Dreams, some researchers suggest, may be default mode activity operating without the regulatory influence of the prefrontal cortex. The self-narrative continuing but unedited, unmonitored, freed from the constraints of plausibility and time, you wandering. But more thoroughly than you wander when awake. Right now the wandering has probably already begun or is close to beginning. The task-directed, outward-facing parts of the brain are quieting. The default mode is shifting into whatever configuration it takes at the edge of sleep. The narrative is softening. The protagonist is becoming less defined. Somewhere in the hippocampus, today is being sorted. What matters, what doesn't. What gets filed and what gets released. The default mode and the memory systems are in conversation, as they are every night, doing work you won't witness and won't remember doing. The wandering mind settling, not into some song, to something else, something that knows in its quiet biological way that the story can be picked up again in the morning, that the protagonist will still be there, that the network will resume its assembling, its narrating, its careful maintenance of the continuous self when the time comes, For now, it loosens its grip just slightly, just enough. You are not the same body you were 7 years ago. Most people have heard this. It circulates as a fact passed around at dinner tables and in late-night conversations, offered usually as something comforting, this. You can change. You're not fixed. The past is genuinely behind you in a cellular sense. But sit with it for a moment longer than usual. If the cells have turned over, if the proteins have been replaced, if the lipids in your neural membranes have been swapped out and rebuilt and swapped again, what exactly has been holding the story together? The answer is not simple and not fully resolved, but it points somewhere specific. It points to memory. Not memory as a filing cabinet, not memory as storage. Those metaphors flatten something that is actually quite strange. Memory as a process, an ongoing biological act of reconstruction, happening at the synaptic level every time something is recalled. There's a faint sound from somewhere in the house, settling or cooling or something that has no name. It stops. The hippocampus is a small curved structure, one on each side tucked into the medial temporal lobe. Its name comes from the Greek for seahorse. The shape in cross-section is loose enough to suggest one if you're generous. It is involved, critically, in forming new declarative memories, the kind that you can consciously recall. Episodes, facts, the particular sequence of a day, but the hippocampus doesn't store memories the way a hard drive stores files. It encodes them, binds together the various cortical representations that make up an experience. The visual information stored in visual cortex, the emotional colouring processed through the amygdala, the spatial context from the entorhinal cortex. The hippocampus holds the index, the binding, the relational structure. The memory itself is distributed, spread across the brain in the same regions that processed the original experience. To remember is to reassemble. Every time you recall something, the memory becomes briefly unstable. This is called reconsolidation. When a memory is retrieved, it re-enters a labile state, malleable, editable, susceptible to modification before it is restored. New information present at the time of retrieval can be incorporated. Emotional context can shift the memory's colouring. The reassembly is not always faithful to the original, which means the memories that feel most certain, the ones you've recalled most often, the ones you'd stake something on, are also the ones most thoroughly shaped by every previous retrieval. You've been editing your own past continuously without knowing it was editing. This is not a flaw, or rather, it may be a flaw in terms of archival accuracy, but it appears to serve a function. Memories that reconsolidate can be updated. Fears can be weakened during reconsolidation if the context of retrieval is safe enough. Associations can shift. The past held in biological tissue is not sealed. It remains at least partially responsive to the present. There's a specific kind of memory worth pausing on here. Autobiographical memory. The memory not just of events, but of yourself within events. The memory that generates the sense of a continuous self moving through time. The same self who was embarrassed in that hallway at 14, who felt something open up unexpectedly one afternoon years later, who is lying here now following a thread of thought towards sleep. The continuity of self across time is, in large part, a memory phenomenon. Remove the ability to form new autobiographical memories, as happens in certain forms of hippocampal damage, and the self becomes stranded in time. The person exists fully in the present moment. They feel, they respond, they have personality, preferences, characteristic ways of being. But they cannot add to the story, cannot connect this moment to the next in a way they'll be able to retrieve tomorrow. The self persists in those cases, but it stops accumulating. Sleep is when much of the accumulation gets sorted. During slow-wave sleep, the hippocampus replays the day's experiences, rapidly, compressed, in a process called sharp-wave ripple replay. It appears to be transferring information to the cortex, moving the day's events from temporary hippocampal encoding toward more distributed, more stable cortical storage. This is consolidation, the night's work of deciding what matters. Not all of it makes the transfer. Sleep appears to be selective, prioritizing emotionally significant memories, novel information, experiences that connect to existing knowledge structures. The rest fades. The details that didn't matter loosen and dissolve. By morning, the self's archive has been quietly edited. Certain things have become more stable, more integrated. Others have been released. You wake up slightly different from who you were before sleep. Not dramatically, but the consolidation has occurred, the story has been updated. What remains stable across all of this, across the cellular turnover, the reconsolidation, the nightly sorting, is something more like a pattern than a substance, not the specific molecules, not even the specific synaptic weights, which shift continuously, something more abstract. The relational structure, the characteristic way the memories connect to each other, the emotional signature that runs through autobiographical recall, the consistent thread of first-person perspective that makes all of these memories feel like yours. That thread is not stored anywhere in particular. It emerges from the pattern, and the pattern is maintained, partially, imperfectly, surprisingly robustly, by sleep. By the hippocampal replay running right now or close to now, in brains that have surrendered enough wakefulness to allow the consolidation to begin. By the slow oscillations of slow-wave sleep that coordinate the transfer. By the REM periods that follow, where the emotional texture of memories appears to be processed separately, integrated into the broader architecture of how you understand your own life. The self, held together by a night's work, done quietly, done without your participation, done as most of the important biological things are while you weren't watching. There's something almost tender about it, I think, that the continuity of selfhood, the thread connecting who you were to who you are, is maintained not by effort but by tissue. Not by will, but by a small curved structure replaying your day in compressed bursts while you sleep. It doesn't ask whether the memories deserve to be kept. It doesn't editorialize. It sorts according to criteria you didn't set and couldn't override. And by morning the archive is different than it was, and you are, barely perceptibly, but genuinely, not quite the same as the person who fell asleep. The pattern persists. The cells have already begun their slow replacement. The synaptic weights are already shifting slightly from the day's activity. Somewhere in the medial temporal lobe the replay has begun or will begin. Rapid, quiet, invisible. Holding the story together one more night. Not perfectly, nothing intersecting in biology is perfect. But well enough. Well enough that you'll wake up still knowing your own name. Still carrying the thread. Still, recognizably the one who started reading this. You are not perceiving the world, you're perceiving your brain's best guess about the world, updated continuously by incoming evidence, running slightly ahead of the moment, never quite catching up. This is not a philosophical position. It is a description of neural architecture. The signal that travels from your retina to your visual cortex takes time. Milliseconds, not much, not enough to matter in ordinary experience. But the brain, it turns out, does not wait. It has already issued a prediction about what the visual input will contain before the input fully arrives. The prediction is generated by higher cortical regions and sent downward, toward the sensory areas, where it meets the incoming signal and the two are compared. If they match, the prediction is confirmed, quietly, without fanfare. If they don't match, If the incoming signal carries something unexpected, the discrepancy generates what researchers call a prediction error. And that error travels upward, loudly demanding attention and correction. What you experience as perception is mostly the confirmation of predictions you didn't know you were making. The blanket has a slight unevenness near the left side, a fold you've been half aware of for some time without doing anything about it. This framework, predictive processing, or active inference in its broader form, has become one of the more generative ideas in contemporary neuroscience. Not everyone accepts its strongest versions. There are genuine debates about how far the predictive architecture extends, which systems it governs, whether it explains as much as its proponents suggest. But the core finding is robust. The brain is not a passive receiver. It is a prediction machine, constantly modelling, constantly anticipating, constantly comparing its models to incoming data, and updating when the data pushes back. The world you experience is, in large part, a construction, not a false construction, not an illusion in any dismissive sense. A construction in the precise sense, built from materials, sensory signals, but shaped by prior expectations, filtered through context, organized according to predictive models refined over a lifetime of experience. The extended metaphor here is of a cartographer who draws the map before visiting the territory, then corrects it on arrival. Most of the time the corrections are minor. The territory roughly matches the map. The errors are small, the updates are quiet. Occasionally the territory is genuinely surprising, a prediction error large enough to break through, to demand revision, to produce the specific neural signature of something unexpected just happened. The startle, the double take, the moment of genuine not knowing before the model catches up. Between these moments of correction you move through a world that is, in a functional sense, already known, already anticipated, already predicted. And the cartographer let the metaphor dissolve here. The cartographer is not a person. There is no central drafter. The prediction is distributed, generated by multiple hierarchical levels simultaneously, no single region in charge. Where this becomes strange, where it stops feeling like a technical description and starts feeling like something worth sitting with, is when you apply it to the self. Because the brain doesn't only model the external world, it models the body, it models its own internal studies, and it appears increasingly to model the self, to maintain a predictive model of who you are, what you will do, how you typically respond. The self in this framework is a prediction, not metaphorically. As a computational description, the brain maintains a generative model of the entity it inhabits. It predicts moment to moment what sensations this entity will experience, what actions it will take, what its internal state currently is. These predictions are compared against incoming interoceptive and exteroceptive signals. Errors are used to update the model. You, as you experience yourself from the inside, may be the output of this process. The brain's best current hypothesis about who is here. I find this genuinely difficult to hold without it slipping into something it isn't. It doesn't mean the self is unreal. A prediction isn't the same as a fiction. The model is causally connected to the thing it models. It shapes behavior. It influences perception. It feeds forward into the next moment's predictions. The self that the brain generates is, in a meaningful sense, the self that acts in the world. But it is generated, and like all predictions, it is subject to revision. There are conditions in which the predictive self-model breaks down in specific legible ways. In psychosis, the error signaling system appears dysregulated. Prediction errors become too large, too frequent, leading the brain to update its model based on noise rather than signal. The self becomes unstable, unreliable, producing the particular terror of not knowing what is real about one's own experience. In depersonalization, something different happens. The prediction confidence may become too high, the model too sealed, such that incoming sensory data about the body and the world fails to update the sense of self. The result is the opposite, a self that feels too certain, too static, unable to be moved by its own experience. These are not arbitrary failures. They follow from the architecture. When the predictive machinery goes wrong, it goes wrong in ways that illuminate how it works when it goes right. Right now, the predictive machinery is doing something specific to you. The model of your body predicts a certain level of sensory input. The pressure of the surface beneath you, the temperature of the air, the weight of your own limbs. These predictions are being confirmed continuously by incoming signals that match well enough to pass without error. The prediction about yourself, about who is here, experiencing this, is also being confirmed, quietly, without fanfare. No large errors, no significant updates required. The model holds, and the model holding is, in a biological sense, what it feels like to simply be yourself. Not a discovery, not an achievement. The absence of significant prediction error, maintained continuously, expressed as the unremarkable, constant, taken for granted sense of being you. Strange that the most ordinary feeling, the baseline of selfhood, should turn out to be the output of a process this intricate. Strange that the brain should work this hard to produce something that feels like nothing at all. But the alternative, a brain that waited passively for the world to arrive before responding, wouldn't survive. The prediction runs ahead because it must. What happens to the predictive self during sleep is not fully settled. The model doesn't switch off. During REM, the brain continues generating predictions, and without the grounding of real sensory input, the errors cannot be corrected by reality. The model runs forward, unchecked, generates scenarios, populates them with figures, produces the particular confident strangeness of dreams, where everything feels real and nothing is required to be consistent. The dreaming self is still a predicted self, just predicted without the corrective pressure of the world. Loose, generous with its own logic, willing to be other people, to be in places that don't exist, to accept impossible premises with complete equanimity. The prediction will tighten again in the morning. The sensory signals will return, the errors will resume. The model will be corrected back towards something stable, something continuous, something you'll recognize as yourself without having to think about it. For now, the corrections are slowing. The incoming signals are quieting. The prediction runs forward into a space with less and less to push back against it. The self, still here, still predicted, still somehow holding, but looser than it was an hour ago, and getting looser still. The brain is not symmetrical. You probably knew this in some abstract way. Left hemisphere, right hemisphere. Language here, spatial processing there. The rough division familiar enough to have entered popular culture in distorted form. But the actual asymmetry is stranger and more specific than the popular version suggests. And one aspect of it bears quietly on everything this video has been circling. In the 1960s, a neurosurgeon named Joseph Bogan, working with Roger Sperry and a young researcher named Michael Gazzaniga, began studying patients who had undergone corpus callosotomy, a procedure where the thick bundle of fibers connecting the two hemispheres is surgically severed, typically to reduce severe epileptic seizures. The patients seemed on the surface largely normal. They walked, they talked, they reported feeling fine, but under controlled experimental conditions. Something became visible that ordinary life concealed. The two hemispheres, disconnected, behaved differently. The left hemisphere, in most people, the one with language, could describe and explain. The right hemisphere could act but not narrate. When the right hemisphere was shown an image and prompted to respond, the left hemisphere, which hadn't seen the image, would immediately generate an explanation for the response, confabulated, invented, stated with complete confidence. Gazzaniga called the mechanism responsible the interpreter, a module or a functional tendency in the left hemisphere that generates explanations for behavior and experience, whether or not it has access to the actual cause. Something outside has gone quiet. A sound you'd stopped registering has simply ceased. Sit with what this implies. The narrator of your experience. The voice that says, I did this because, I felt that because, I am the kind of person who may not have full access to the processes it's narrating. It constructs the story from available evidence. It fills gaps. It produces coherent, grammatically intact, emotionally plausible explanations for things that may have been decided by processes it cannot see. The self-story is real. It's being generated by real tissue using real information. But it may be, at least partially, a post hoc account. I want to be careful here because it's easy to slide into something misleading. The interpreter isn't lying, it's not a pathology. It's doing exactly what a system without complete information does, making the best inference available, generating coherence from partial data. The confabulation in split-brain patients is an extreme version of something that may operate, in milder form, in all of us. You act, you feel, you choose, or something in you chooses, and then a part of your brain, rapid, confident, fluent, writes the reason. The left hemisphere's dominance for language in most people is not absolute, and it's not the same across all individuals. Left-handers show more variable lateralization. Some people have more bilateral language representation. The asymmetry is a tendency, not a rule, a statistical feature of the population, not a fixed law of individual brains. But the interpreter tendency, the drive to generate explanatory narrative, appears broadly consistent. It seems to be something the language-dominant hemisphere does because that's what language does. Language is, among other things, a causal story generator. Subject, verb, object, agent, action, reason. The grammar of self-narration is built into the grammar of language itself. There's a finding from social psychology that converges on this from a different direction. When people are asked to explain their preferences, why they chose this poster over that one, why they prefer this jam to another, they produce explanations readily, fluently, with apparent confidence. But when the choice was actually made under conditions that precluded the stated reason, when the poster was switched without their knowledge, when the jams were identical, the explanations continue, undisturbed. The phenomenon is called choice blindness, and what it suggests is that the explanation is not retrieved from the decision process. It is generated afterward, in response to the question, the interpreter, running, finding a reason, presenting it as memory. You've done this, I've done this. The confidence with which we narrate our own motivations is not always proportional to our actual access to them. This isn't a reason for distrust of the self, it's a reason for a particular kind of gentleness toward it. The self that narrates is doing its best, it has the information it has, it generates coherence because coherence is functional. A self that produced fragmented, contradictory accounts of its own behavior would struggle to act consistently, to maintain relationships, to plan. The story serves a purpose even when the story is partially invented. What the split-brain research revealed, slowly across decades of careful work, is that what feels like unified conscious experience may be the output of multiple systems that don't always communicate fully. The right hand and the left hand, in the most literal sense, sometimes didn't know what the other was doing. Not metaphorically, literally. One hemisphere would reach for an object while the other reached for something different, and neither would experience this as conflict until the behavior became visible. In ordinary brains, the corpus callosum coordinates the two hemispheres continuously, billions of fibers transmitting at a speed, maintaining the integration that makes unified experience feel seamless. But the seams exist. They are just hidden. The circular quality of this, the way it returns to where it started, is something I notice without entirely resolving. The brain generates the self. The self experiences the brain's activity as unified and continuous. The left hemisphere narrates the experience. The narration feels authoritative, and the authority of the narration is itself a product of the brain. The story that says I know why I did that is generated by the same system that did the thing, which doesn't have full access to itself, which generates coherence anyway because coherence is what it does. Round and round. Not a problem to be solved. A feature of the architecture. Right now the interpreter is probably still running quietly, generating small accounts of this moment, contextualizing, connecting, doing what it does even as the rest of the system slows. At some point tonight it will quiet. The narration will soften and then stutter and then stop, or become something unrecognizable as narration. The loose associative drift of hypnagogia, the dissociated strangeness of dreams, and in the morning it will resume, confident, fluent, ready with reasons. The story will continue from wherever it left off as if it had never paused, as if the self who fell asleep and the self who woke are the same self without interruption. The interpreter making sure the seams don't show. You were a different person at 3 p.m. yesterday than you are right now, not philosophically, chemically. The ratio of cortisol to melatonin in your bloodstream has shifted. The concentration of norepinephrine in your synaptic clefts is different. The sensitivity of your dopamine receptors has changed, subtly, with the hour. None of this required a decision. None of it announced itself. It just happened. The way tides happen, the way temperature drops after dark without anyone lowering anything. Cortisol peaks in the early morning somewhere around 20 to 30 minutes after waking. This is called the cortisol awakening response, and it is one of the more reliable hormonal events in human biology, consistent across most people, modulated by sleep quality, stress, light exposure, but fundamentally present. It is, in a functional sense, the hormone that initiates you, not metaphorically. Cortisol in the morning triggers glucose release, increases alertness, sharpens attentional focus, primes the immune system, raises blood pressure towards a functional range. It is the biochemical substrate of being ready for the day. And the self that moves through the morning, the one that feels relatively capable, relatively clear, relatively able to engage with the world, is partly that, partly a cortisol event. There's a particular quality to the dark right now, not heavy, just present, the kind you stop noticing after a while. By afternoon, cortisol has dropped. The curve descends through the day, reaching its lowest point in the early hours of the following morning, somewhere around 2 or 3 a.m. You've probably felt this without naming it, the specific flatness of late afternoon. Not fatigue exactly, not the heavy limb weight of genuine tiredness, but a thinning. Thoughts that feel slightly less adhesive. Motivation that requires slightly more activation energy than it did at 10 a.m. That's not weakness. That's the descending limb of the cortisol curve. The self doesn't disappear, but it becomes less insistent, less forward-leaning, less convinced of its own projects, estrogen does something to verbal memory. This is documented, if not entirely understood. In people with higher circulating estrogen, certain verbal memory tasks show measurably better performance. The mechanism involves estrogen receptors in the hippocampus. Estrogen appears to facilitate synaptic plasticity in memory-forming circuits, at least in some contexts, which means, across a monthly hormonal cycle, in people who have one, the self that retrieves and recounts personal history is not neurologically identical from week to week. The narrative capacity fluctuates. The ease with which the autobiographical thread is accessed shifts. The story of the self is told by a brain whose chemistry is not constant. Testosterone alters risk assessment, not by making people reckless exactly. That's an oversimplification that the data doesn't quite support. But in controlled studies, higher testosterone levels correlate with reduced sensitivity to threat signals, increased willingness to approach uncertain situations, and subtly altered social perception. Specifically, a tendency to read neutral faces as more dominant or challenging. The world under different hormonal conditions is populated by slightly different people. The self that navigates that world responds to a different social landscape. Not because the landscape changed, but because the chemistry that interprets it did. I want to be honest about what the research does and doesn't establish here. The relationships between hormones and behavior are real. The mechanisms are increasingly understood at the receptor and circuit level, but the effect sizes are often modest. Individual variation is enormous. The same hormonal shift that meaningfully alters mood and cognition in one person may produce barely detectable changes in another. The biology is real. The determinism would be an overstatement. What's true is that the hormonal environment is one of the inputs, significant, continuous, largely unnoticed, into the system that generates the self. Not the only input, not an override, but a context. A chemical weather that shapes the processing without fully determining the output. Oxytocin is the example that requires the most care. It has a reputation, the bonding hormone, the love hormone, the chemical of connection. This reputation is not entirely wrong. Oxytocin is released during physical touch, during breastfeeding, during orgasm, during moments of close social contact. It acts on receptors in the amygdala and reduces fear responses, increases trust, facilitates social approach behavior. But it also increases in-group favoritism. In some studies, it enhances negative responses toward out-group members. The hormone that makes you more open to the people near you may, under certain conditions, make you less open to people you've categorized as distant. The same molecule, both things. The self shaped by oxytocin is warmer and more bounded simultaneously. Melatonin is rising in you now or has been rising for some time. The suprachiasmatic nucleus, a small cluster of neurons in the hypothalamus, your body's master clock, registered the fading of light hours ago and began signaling the pineal gland to release it. Gradually, in a slow curve that will peak sometime in the middle of the night and then taper toward morning. Melatonin doesn't cause sleep directly. It signals timing. It tells the brain, this is the biological night. Adjust accordingly. Core body temperature begins to drop, heart rate slows. The alerting systems that kept the day's self coherent and forward-facing begin their scheduled quieting. The self becomes less architectural, less built, more like something settling than something constructed. What's strange when you sit with all of this is not that hormones influence who you are. That part, once stated, seems almost obvious. Of course, the chemical environment shapes experience. What's strange is how continuous it is. There's no hormonal baseline that represents the true self, the one that would exist without chemical influence. The chemistry is always present, always shifting, always participating in the construction. The self at peak cortisol is not more real than the self at low cortisol. The self mid-cycle is not more authentic than the self at the end of it. These are all versions, all genuine, all biologically grounded, all doing their best to maintain continuity across a chemistry that never stops moving. The melatonin curve is still rising. Somewhere in the hypothalamus, the clock is running. Not a metaphor, an actual circadian oscillator, genes switching on and off in a roughly 24-hour cycle, tuned by light and reinforced by behavior and temperature, and the consistent pressure of a life lived in repeated rhythms. It doesn't know you specifically. It knows the cycle. It runs the same program it ran last night, and will run tomorrow night and ran in your grandparents and in their grandparents and in animals that preceded all of them. Ancient, precise, completely indifferent to what you were thinking about. The self riding a tide it didn't make, going where the tide goes, which right now is here, which is toward quiet, which is toward the particular hormonal configuration of a body preparing without drama to release the day. Before you had a name for yourself, you were already being shaped. Not by experience yet, not in any way you could have known about. By chemistry, by timing, by the particular sequence of genetic switches activating in a specific order across the weeks of early neural development, building the architecture that would later house everything you'd come to call yourself. The self that feels so immediate, so interior, so irreducibly yours. It was under construction long before it had any awareness of being constructed. There is a process called neural migration that occurs during fetal development, roughly between the 6th and 24th week of gestation. Neurons newly born from progenitor cells lining the ventricles travel outward along the scaffolding of radial glial cells toward their final positions in the cortex. They move in waves, each wave passing through the previous one, building the cortex from the inside out. The deepest layers form first, the outermost layers last. By the time this migration is complete, the basic laminar architecture of your cortex has been established. 6 layers of neurons, each with characteristic connectivity patterns, each contributing differently to the processing that will eventually support thought, perception, memory, selfhood. None of this required experience. It ran on genetic instruction alone. The foundation was laid before any experience existed to shape it. The room feels slightly cooler than it did earlier. Not uncomfortably, just different. The night settling into itself. And then experience began. From birth, and in some systems before birth, the nervous system starts responding to input. Sensory information arrives. Neural activity patterns form. Synaptic connections are made and tested and pruned according to a principle that neuroscientists summarize as neurons that fire together, wire together. The connections that carry traffic survive. The ones that don't are eliminated quietly, efficiently in a process called synaptic pruning that continues across childhood and accelerates again in adolescence. The brain you have now is partly defined by what was removed. There were periods when certain kinds of experience were disproportionately influential. Researchers call these critical periods or sensitive periods, windows of heightened neural plasticity during which particular inputs have outsized effects on circuit organization. The visual system has one, early in infancy. Language acquisition has one, extending through early childhood. Emotional regulation circuits appear to have one, shaped heavily by early attachment experiences. During these windows, the brain is not simply learning. It is calibrating, setting parameters, establishing default ranges for stress response, for social expectation, for the baseline sense of whether the world is safe or not. These calibrations run deep, deeper in some cases than later experience can easily reach. Attachment is the one worth staying with longest. In the first year of life, the relationship between an infant and its primary caregivers, the quality of attunement, the consistency of response, the degree to which distress reliably produces comfort, appears to shape the development of the stress response system in ways that persist. The hypothalamic pituitary adrenal axis, the hormonal cascade that manages cortisol release in response to perceived threat, is calibrated during this period. Secure, consistent early care appears to produce a system that responds to stress proportionally and recovers efficiently. Inconsistent or frightening early care can produce a system that is either chronically elevated or blunted, set too sensitive, or set too defended. The setting is not permanent. The brain retains plasticity. Later experience can shift the calibration, sometimes significantly. But the early setting is real. It is biologically encoded, and it shapes in ways most people never trace. The particular emotional texture of being oneself, the baseline from which all subsequent experience is measured. You carry that calibration right now, not as a memory, not as something you can retrieve or examine directly as a parameter. A characteristic response curve built into the circuits that process threat and safety and social belonging. It influences how you read ambiguous situations, how quickly you settle after disturbance, how much reassurance feels like enough, what quality of silence feels safe versus what quality of silence feels wrong. You didn't choose any of it. It was set before you had the neural architecture to choose anything. Adolescence brought a second wave. The prefrontal cortex, late to mature, still under significant construction through the mid-20s, undergoes extensive remodeling during adolescence. Synaptic pruning accelerates. White matter tracks thicken as axons are myelinated, increasing conduction speed. The connections between the prefrontal cortex and the limbic system, between the regions that regulate and the regions that generate emotional response, are being established and refined. This is why adolescence feels the way it feels, to those inside it. The emotional generation system is largely mature. The regulatory system is still being built. The self during this period is not incomplete in any pejorative sense. It is mid-construction, running on a partially assembled architecture, doing its best with the circuits available, building the very structures that will later make it feel more stable. The turbulence is structural. It was always going to be there. What persists from these periods is not memory mostly. The specific episodic content is the particular afternoons, the faces, the conversations may or may not survive. Memory in early childhood is sparse for structural reasons. The hippocampus is still maturing. The prefrontal regions necessary for encoding explicit memories are still developing. What persists is something below memory: pattern, reflex, expectation, the implicit knowledge that the body carries without being able to articulate, the knowledge of how relationships feel, how danger announces itself, how much of oneself it is safe to show. This knowledge lives in the circuits that were shaped during those early windows. It influences the self that sits here now, at the end of this day, without those early experiences necessarily being accessible to recall. There is something irreversible about developmental time that I find worth acknowledging plainly. The sensitive period for a given system closes. The window doesn't stay open indefinitely. What happened during that period, whatever the quality of experience, whatever the calibration that resulted, was incorporated into the architecture at a time when the architecture was most susceptible to being shaped. This is not tragedy. It is not destiny. The brain's plasticity extends across a lifetime in ways that early models of critical periods underestimated. But the early shaping was real. The circuits it produced are real. And the self that emerged from childhood, from that long, slow process of pruning and calibrating and constructing, arrived at adulthood carrying the mark of conditions it didn't choose, and, in many cases, cannot fully remember. You were built during a time you don't entirely have access to, by processes that required no consent and left no receipts, and the self that resulted, this particular configuration of response curves and attachment patterns and stress thresholds and characteristic ways of being in the world, and feels from the inside like simply who you are. Because it is. It was made. It is genuinely yours. Both things at the same time without contradiction. The development never fully stops. Even now, even tonight, in the quiet, in the particular hormonal state of a brain preparing for sleep, the prefrontal circuits are being slightly refined by the day's experience. The stress response system is taking its own subtle calibration from how this day resolved. Sleep will do its part, consolidating what was learned, pruning what wasn't used, moving the day's experience into the architecture. The construction continues, more slowly now, with less urgency than it had in those early years, but still quietly, without drama, without asking for acknowledgement, still building. Long before anything you would recognize as a brain existed, something was already solving the problem of self, not consciously, not with anything resembling intention, but chemically, molecularly, in the slow, patient language of proteins recognizing other proteins, something in the earliest complex organisms was learning to distinguish between what belonged and what didn't. This is where the immune self begins, not in the nervous system, not in memory or perception or the particular architecture of selfhood that this video has been tracing. Earlier, in tissue. In the oldest biological question there is, what is me? What is not? Every nucleated cell in your body displays on its outer surface a set of molecular markers called the Major Histocompatibility Complex, MHC molecules, in most of the literature, though in humans they are often called HLA antigens. These markers are your cellular signature, a molecular passport unique to you encoded in your genome, expressed continuously on cell surfaces throughout your life. Your immune cells, the T cells and B cells and natural killer cells that constitute the adaptive and innate immune systems, learn during their maturation to recognize this signature as self. The process happens primarily in the thymus, a small glandular organ behind the sternum that is most active during childhood and slowly involutes with age. In the thymus, immature T cells are educated. They are exposed to the body's own molecular markers. Those that react too strongly to self-markers are eliminated. Clonal deletion, the immunologists call it. Those that fail to recognize self-markers at all are also eliminated. Only the ones that can recognize the signature without attacking it are permitted to mature and enter circulation. The immune system learns, in other words, what you are, and it learns by destroying everything that gets the answer wrong. There's a faint taste of something at the back of the throat. Not unpleasant, just present. The body doing what it does. The scale of this is worth pausing on. Your immune system maintains a working catalogue of self that covers somewhere in the range of 37 trillion cells, each one displaying its markers, each one being continuously, passively assessed by the immune cells that patrol the tissues, moving through the bloodstream, sampling surfaces, checking signatures. This is not a periodic scan, it is continuous, Right now, while you lie still and the rest of the body quiets toward sleep, the immune surveillance continues. Natural killer cells drifting through blood vessels, macrophages stationed in tissues, dendritic cells sampling the molecular environment and carrying their findings back to lymph nodes, where the next level of response is calibrated. The body never stops checking that it is still itself. The metaphor that assembles itself here, and I'll let it run briefly before dissolving it, is of a vast, slow, distributed library where every book knows its own shelf and reports any displacement. Not a central librarian, no single authority. The knowledge of self is held in the system collectively, in the educated T cells, in the antibody repertoire, in the pattern recognition receptors of the innate immune system that have been refined across hundreds of millions of years of evolutionary pressure. The library has no director. It simply knows, and it keeps knowing continuously with the reliability that only fails in specific, legible ways when specific, legible things go wrong. Let the metaphor go now. The reality is more interesting than any comparison. Autoimmunity is what happens when the system mistakes self for non-self. The mechanisms vary at molecular mimicry, where pathogen surface proteins resemble the body's own markers closely enough to trigger a cross-reactive response. Breakdown in the central tolerance established during thymic education, regulatory T-cell failure that allows self-reactive cells to escape suppression. The details differ across conditions. The underlying event is consistent. The immune system attacks tissue that carries the correct signature. Rheumatoid arthritis, lupus, multiple sclerosis, type 1 diabetes. These are not random malfunctions. They are failures of a specific recognition system. The system that maintains the cellular definition of self, and their existence reveals, in the way that failures always reveal, the extraordinary precision of the system when it's working correctly. When it works, you don't notice it. The signature is recognized. The tissue is passed. The patrol continues. The self, at the cellular level, is continuously confirmed. There is an evolutionary depth at this that I find genuinely difficult to hold in full. The MHC system is ancient. Versions of it exist in fish, in sharks, in the jawless vertebrates, the lampreys and hagfish, that branched from the vertebrate lineage over 500 million years ago. Even in some invertebrates, related molecular recognition systems operate. The question of self, of distinguishing one's own tissue from foreign material, is not a recent biological problem. It predates nervous systems in anything like their current form. It predates brains. It predates by an enormous margin anything that would generate the kind of self-awareness this video has been exploring. And yet the immune self and the neural self are not unrelated. The immune system and the nervous system communicate. This is not metaphor and not recent discovery, but it took decades to map with any precision. Cytokines, signaling molecules released by immune cells, cross the blood-brain barrier or act on its receptors and influence neural function. During infection or inflammation, cytokine signaling produces what researchers call sickness behavior: withdrawal, fatigue, reduced appetite, social disengagement, altered mood. These are not side effects. They appear to be adaptive, conserving metabolic resources for immune function, reducing exposure to additional pathogens, allowing the body to direct its energy toward the biological work of recovery. But the relevant point here is the directionality. The immune system talks to the brain. Its current state, the level of circulating inflammatory signals, the degree of active immune response, the chemical signature of what the body is currently defending against, is communicated upward, and it influences the neural processing that contributes to the sense of self. You feel different when you're ill, not just physically uncomfortable. Something shifts in the quality of being yourself. The world contracts. The self becomes more interior, less outward-facing, less engaged with what is usually engaging. That shift has a molecular basis, the immune system, reporting its status to the brain, altering the conditions under which the self is generated. What I find myself uncertain about, and the uncertainty feels honest rather than evasive, is the exact boundary between the immune self and the neural self. We tend to treat them as separate systems that occasionally communicate, but they develop in parallel. They share molecular signals. They both perform in their different registers something like recognition, the ongoing determination of what belongs, what doesn't, what requires response. Whether these are two implementations of a single deeper biological principle, or genuinely distinct systems that happen to overlap at the edges, I don't think that question is settled. The data supports both readings, depending on how you frame it. The immune system is doing its work right now. Somewhere in your peripheral blood, T cells are completing their patrol. Macrophages in your gut lining are sampling the microbial environment, a negotiation that has been running continuously since early infancy, establishing and maintaining the particular microbial community that your immune system has learned to tolerate. The tolerated and the rejected, the self and the not self. The boundaries maintained not by thought or memory or the particular circuits of neural selfhood, but by protein recognizing protein, by an ancient molecular grammar spoken in tissue. Your body has been asking this question since before you were born. It is still asking it, right now, in the dark, while the rest of you moves toward quiet. The answer it keeps arriving at, the answer it has been arriving at continuously across your entire life, is the same one, not dramatic, not announced, just this particular molecular signature, this particular configuration of markers displayed on 37 trillion surfaces. This is the one, this is what we protect, and below that, somewhere further down, below the immune self and the neural self and the hormonal self and the predictive self, and all the other layers this video has been slowly turning over, something else. Something the immune system doesn't address. Something that has no molecular marker, no receptor, no antibody. The question of whether any of this is felt from the inside by something, that question belongs to a different chapter. There is a condition called Cotard's syndrome. The person who has it believes they are dead. Not metaphorically, not as depression's dark idiom. I feel dead inside, I feel like nothing, literally. They report with calm conviction that they no longer exist, that their organs have stopped functioning, that they are a corpse moving through a world that has continued without them. Some stop eating, not from sadness, from a logical conclusion. The dead do not require food. It is rare. It appears most often in the context of severe depression or following certain neurological events, strokes, brain injuries, encephalitis. The neuroimaging data in the cases where it has been obtained shows something specific, dramatically reduced metabolic activity across large regions of the cortex, particularly areas involved in integrating bodily sensation with self-referential processing. The body is still sending its signals, the organs are still reporting, the interoceptive data is arriving, but the system that integrates that data into the felt sense of being alive, of being a self that inhabits a functioning body, has gone quiet. And in the absence of that integration, the brain generates the most coherent explanation it can for the absence of felt aliveness. The interpreter, still running, finding the only story that fits. Somewhere outside something moves once and doesn't move again. A leaf, an animal, it doesn't matter. Depersonalization is more common. The person experiencing it reports feeling detached from their own mind or body, watching themselves from outside as if they are a spectator of their own experience. The world may feel flat, two-dimensional, unreal. Their own face in the mirror may seem like a face they are studying rather than a face they're wearing. It is distressing, usually. The person knows intellectually that they are present, that the person they're watching is them. The knowledge doesn't help. The feeling of ownership over the experience is what's missing, and knowing it's missing doesn't restore it. Depersonalization appears to involve dysregulation in the way the prefrontal cortex modulates the amygdala and the insula. The emotional and interoceptive processing continues. The regulatory suppression of it is too strong. The result is a self that processes without feeling owned. The experience happens. It just doesn't feel like it's happening to anyone. Anosognosia is different again. After certain strokes, particularly affecting the right hemisphere, patients may be completely unaware of a significant deficit. A person with left-sided paralysis may, when asked to lift their left arm, report that they have done so. When shown that the arm hasn't moved, they may confabulate a reason. They are not lying. They genuinely do not perceive the deficit. The awareness of the body's current state, which we've been tracing all through this video, through proprioception and interoception and the ongoing self model, has been interrupted at a specific point. The body's signal is not reaching the system that would generate awareness of it. And without awareness of the deficit, there is no experience of having a deficit. The self-model continues, undisturbed, missing the update. Gazzaniga's interpreter again, narrating confidently in the absence of the information it would need to narrate accurately. Somatoparaphrenia goes further. Following certain right hemisphere strokes, patients may not just be unaware of their left limb's paralysis. They may deny that the limb belongs to them at all. The arm is there. They can see it. But they report with varying degrees of distress or equanimity depending on the case that it is not their arm, that it belongs to someone else, that it has been placed there or attached without their consent. The limb carries no familiar sense of ownership, and ownership, the raw pre-reflective sense that this body is mine, that these sensations belong to me, turns out to be a neurological achievement, generated, not given. When the relevant circuits are disrupted, the ownership simply isn't there. The arm remains. The feeling that it's yours doesn't. I want to stay with that for a moment, because I think it's one of the most clarifying things in this entire area of research. Ownership of your own body is not obvious. It is not automatic in any deep sense. It is produced continuously by circuits that can fail in specific ways. And when those circuits fail, the experience of having a body, of being located in it, of its sensations being yours, doesn't necessarily follow. Most of us never notice this. The ownership is so consistent, so unbroken across a lifetime, that it becomes invisible. The way the floor is invisible, not because you can't see it, but because you stopped looking at it. These conditions make the floor visible. They show, by interruption, what is ordinarily accomplished without effort. Dissociative identity disorder sits in a different category and deserves care in how it's described. It is contested in ways the other conditions aren't, not its existence, which is well documented in clinical literature, but its mechanisms and its relationship to trauma, memory, and the nature of identity itself. What the documented cases consistently show is that the sense of a single, continuous, unified self, the self this video has been exploring, is not structurally inevitable. The same nervous system, in certain conditions, can organize itself around more than one relatively consistent self-state, each with characteristic affect, memory access, behavioral repertoire. What this suggests about the self is not that it is fragile or illusory. It suggests that the unity we experience as normal is an achievement, an active, ongoing integration of components that are, in some sense, capable of operating more separately. The integration is real, it's just not free, it requires conditions. What runs through all of these, catarrhs, depersonalization, anosognosia, somatoparaphrenia, is not randomness. Each one disrupts a specific component of what this video has been assembling chapter by chapter. The felt sense of being alive, the ownership of experience, the accurate model of the body's current state. The attribution of the body's parts to the self. Each failure is legible. Each one points to something that was being quietly accomplished before it stopped being accomplished. The self is not one thing that breaks in one way. It is many processes, each breakable separately, each normally so seamlessly integrated that the seams are invisible. The seams are invisible in you. Right now, the interoceptive signals are arriving and being integrated. The body schema is accurate and updating the sense of ownership over your own experience. The fact that these sensations are felt as yours, that this particular darkness and weight and warmth belong to the self that is reading this. That ownership is intact. It is easy to not notice this. It requires no effort on your part. That's exactly what makes it so easy to miss. The self, when it holds without announcing itself. It simply continues. Signal arriving, integration occurring, ownership maintained. The interpreter narrating, the predictive model updating, the immune system confirming, the hormones shifting, the memory consolidating, the default mode idling. All of it together producing the unremarkable, taken for granted, extraordinarily complex fact of being a self who is lying here in the dark, growing quieter, nothing broken, everything quietly working. At some point tonight, maybe soon, maybe already beginning, you will stop narrating, not decide to stop, not choose it. The narration will simply become unsustainable. The way a sound becomes unsustainable when the thing producing it runs out of whatever it runs on. The default mode will lose its coherence. The interpreter will drop a sentence mid-construction. The predictive self model will stop demanding confirmation from the world, and you will go somewhere that has no reliable witness. The threshold has a name, hypnagogia, from the Greek for sleep and guide. The state between waking and sleep proper, where the brain is neither fully one thing nor the other, where the regulatory authority of the prefrontal cortex has begun to loosen its hold on the associative regions, and those regions, freed from oversight, begin generating their own content. You've been here before, many thousands of times. You probably don't remember most of them. Images arrive without context, a face you don't recognize with a name you're certain of, though the certainty won't survive waking. A sentence that almost means something, the specific sourceless feeling of falling, and the small muscular jerk that follows, the hypnic jerk, a brief burst of motor activity as the brainstem's postural maintenance systems register the loosening of waking muscle tone and respond for a moment, as if to a stumble that isn't happening. The body still paying attention. Even here, the weight of your own hand, wherever it is resting. You may not have thought about it until just now. N1 sleep is the lightest stage. The electroencephalogram, if you were being monitored, would show the high-frequency, low-amplitude waves of waking beginning to give way to slower rhythms. Alpha waves decreasing, theta waves appearing, the brain's electrical activity shifting register. Consciousness during N1 is still present, in some attenuated form. People woken from N1 often report they weren't asleep, that they were just thinking, just resting with their eyes closed. The experience of sleep hasn't yet arrived. Even as the physiology of sleep has begun, the self is still here, thinner, less insistent, but present. N2 arrives without announcement. Sleep spindles appear in the EEG, brief bursts of oscillatory activity, 12 to 15 cycles per second, generated by the thalamus and spreading to the cortex. They appear to serve a gating function, reducing the brain's sensitivity to external sensory input, making it harder for sounds or movements to pull the system back toward waking. The spindles are, in a quiet sense, the brain protecting its own sleep, building small walls against the world, deciding repeatedly not to surface. K-complexes appear alongside them, large, slow waves that seem to be the brain's response to stimuli it has detected but chosen not to act on. The world is still being registered. It is simply being set aside. The self is still here, but it has stopped leaning toward anything. Slow wave sleep, the deep stages, N3, is where the architecture of selfhood undergoes its most significant nightly renovation. The high-frequency activity of waking drops away almost entirely. Large, slow delta waves move across the cortex in coordinated sweeps, 0.5 to 2 cycles per second, the slowest rhythms in the sleeping brain's repertoire. The default mode network, which spent the waking hours assembling the self's narrative, quiets to its lowest activity of the night. The hippocampus begins its replay. The sharp wave ripples we've already touched on, the compressed rerunning of the day's experiences, the transfer of newly encoded material toward cortical consolidation. The self's archive being updated silently, in the absence of the self that the archive belongs to. There is something about this that I find not troubling but worth noticing. The most important memory work of the night happens when the self is least present to witness it. The story is being revised by a process that doesn't consult the protagonist. The self during slow-wave sleep is not suspended in any complete sense. The brainstem continues its maintenance. The immune system continues its patrol. The body schema persists in some basic form, enough that you'll shift position when pressure becomes uncomfortable, enough that the body knows it's a body even when the mind has largely vacated. But the narrative self, the continuous, temporally extended first-person self that has been the subject of this entire video, that self has gone somewhere that can't be reported on. Whatever it is like to be in slow-wave sleep, no one has ever told us. The people who have been there cannot remember having been there. The window is, in the most literal sense, unwitnessed. REM returns the narrative. Partially, strangely. Rapid eye movement, sleep brings a paradoxical activation. The brain's electrical activity resembles waking more than it resembles the deep sleep that preceded it. But the body is more profoundly paralyzed than at any other stage. The brainstem actively suppresses motor output. The muscles fall out and into the sort of body, the dreaming mind generates its world. The default mode network is active again, but without the prefrontal modulation that keeps waking experience coherent and temporally organized. The self in dreams is present. Usually, there is a first-person perspective, a dreamer who moves through the dream, but it is a self freed from the constraints that define it when awake. It can be other people. It can be in places it has never been. It can accept premises. This house has always had this extra room. This person who died is simply here, that waking logic would immediately correct. The predictive self model running without the world to correct it, generating experience from the inside, unchecked. What the dreaming self is exactly, whether it is the same self as the waking self, whether it has genuine subjectivity, whether there is something it is like to be it, or whether the felt reality of dreams is constructed retrospectively in the moments of waking. These questions don't have settled answers. The neuroscience gets careful here. The phenomenology gets complicated. The honest position is that we don't fully know what happens to the self in sleep. We know a great deal about what happens to the brain. The relationship between those two things, between the neural activity and the experience, if any, remains, as it has remained throughout this video, genuinely open. What we do know is this. Every morning across a lifetime the self reassembles, not from nothing, from the architecture that sleep maintained, the consolidated memories, the restored synaptic homeostasis, the neurochemical systems reset by hours of inactivity, the immune function refreshed, the default mode network ready to resume its narrating. The self that wakes is not identical to the self that slept. Small differences, a memory more stable, an emotion processed, a connection between ideas that didn't exist the night before, but continuous enough, recognizable enough, carrying the thread. The reassembly is so reliable that you have never once woken up and not known who you were. Think about that for a moment. Every morning, without fail, the self returns to itself, not because it was stored somewhere safe while you slept, because the biological conditions for generating it were maintained quietly through the night. And when those conditions were met, when the light changed and the cortisol began its morning rise and the brainstem's arousal systems re-engaged, the self simply resumed, as if it had never paused. Right now the pausing is close. The spindles may already be forming. The threshold may already be thinning beneath you. The self that has been reading this, that followed proprioception into interoception, into mirrors, into the wandering mind, into memory and prediction and hormones and development and the immune system and the fragile circuitry of ownership, that self is preparing without preparation to let go of its own continuity for a few hours. It will come back. It always comes back. But for now, the narration softens. The model releases its grip on the moment. The interpreter lets a sentence go unfinished, and the biological night does what it has always done, quietly, without asking. There is no place in the brain you could point to, no structure, no region, no cluster of neurons that houses the self the way a chest houses a heart. Researchers have looked carefully, with increasingly precise tools, across decades of imaging and Lisian studies and split-brain experiments and careful phenomenological work. What they found instead is process, distributed, interdependent, continuous process. The self is not a location. It is something the brain does, and the brain does it constantly. Through waking and dreaming and the deep wordless hours of slow-wave sleep when the narrative pauses, but the conditions for narrative are carefully maintained. Through childhood and its critical windows and the slow myelination of adolescence. Through the hormonal tides that shift the narrator's chemistry without shifting the narrator's sense of being a narrator. Through all of it, the immune system quietly confirming the body's molecular signature, the default mode assembling the story, the interpreter writing reasons, the predictive model running slightly ahead, the interoceptive signals arriving unlabeled and being given names. Through all of it, something persists. Not a substance, not a soul in any theological sense, and not its absence either. Something more like a pattern that keeps recognizing itself, a process that references itself in its own operation. The strange loop, And this is the closest the biology comes to philosophy without leaving biology, of a system that models the modeler, the brain generating a self that experiences the brain generating a self. Round and round, not a flaw, an architecture. Your breath has slowed. You may not have noticed until just now. What remains at the end of all this is something very simple. You, not explained away by the neuroscience, illuminated by it, made more interesting, not less. The fact that the self is generated doesn't make it less real. Fire is generated. It is still fire. It still burns. It still does what only fire does. The self is still here, still reading or nearly done reading, still located somewhere specific, in a body, in a room, in a particular arrangement of sensation and memory and prediction that has never existed in exactly this configuration before and will never exist again. That specificity is worth something. Not a grand conclusion, just a quiet biological fact. This version, this particular hormonal state, this day's memories not yet fully consolidated. This precise degree of tiredness, this exact configuration of interoceptive signals and predictive models and default mode activity, this has never happened before. And after tonight, after the consolidation and the pruning and the small invisible revisions that sleep will make to the archive, this version will be not gone, but past. The self continues. This moment of it doesn't. It's already moving. You followed this for a long time tonight, through tissue and chemistry and evolutionary time, through circuits that break in legible ways and circuits that hold so reliably you forgot they were holding, through the wandering mind and the predictive model and the small curved structure replaying your day in the dark. I find when I get to the end of these that I'm genuinely grateful you stayed. Not in a formal way, in the way you're grateful when someone sits with the thing long enough to let it actually land. If something in this one settled somewhere useful, if some chapter found you at the right moment, a like does something small but real. It tells whatever algorithm is watching that this kind of quiet is worth surfacing. And if you're not yet subscribed, and this is the kind of thing you want more of, the button is there. No urgency, just it keeps the channel findable for you and for whoever else might need something slow at the end of a long day. There are members of this channel who make these videos possible in a way that's more direct than any algorithm. If you've ever wanted to be part of keeping this space alive, the membership is there. And it matters more than I usually remember to say. And super thanks for anyone who's ever felt moved to use it. I read everyone, and they land heavier than they probably should. The comment section, if you want it, is open. Some of the best conversations I've had about this work have started there, quietly from someone who just wanted to say what a chapter made them think about. For now, the default mode is quieting. The interpreter has nothing left to explain. The predictive model is releasing its grip on the next moment. The immune system continues its patrol. The hippocampus is beginning its quiet work. The melatonin curve is somewhere near its peak. The body knows what to do from here. It has always known. You don't have to hold anything, not the neuroscience, not the question the title asked, not even the thread of yourself, which will still be there in the morning, reassembled from the same conditions that have reassembled it every morning of your life. The self continues, even now, especially now, when you've finally stopped trying to locate it.